Hello and welcome. This is question number 3 for AQA's A2 Physics, Unit 5, as I say, Section B, June 2010. Okay, so this question is about black holes, event horizons and CCD. So we're looking at that aspect of the astrophysics part of it. Okay, so let's crack on with the first question. Most of these are simple knowledge questions, okay? And it's a very kind of easy question, especially compared to question 2, I think. Now, the first part, 3A, says, explain why X-ray telescopes need to be in orbit. Okay, now you need to think, well, what is the effect that the actual atmosphere has here? Because obviously the only difference between a telescope in orbit and a telescope in on the ground of Earth, okay, is the atmosphere. And the only effect, and obviously because it's an X-ray telescope, what basically this question is therefore saying, combining them two things, what's the difference between measuring an X-ray outside the atmosphere and actually inside the atmosphere? Okay, now therefore the question says, what effect does the atmosphere have on X-rays? Okay, well, I don't say that, but it obviously has some effect. Okay, so basically, X-rays are absorbed by the Earth's atmosphere, so it won't give a true reflection, okay, of what is actually out there, or what you're using the X-rays to measure. In other words, a simple way of answering this question is by saying the X-rays are absorbed by the Earth's atmosphere. So if you put an X-ray dish on the surface of Earth, it wouldn't record everything. It would only record some of the X-rays, so it's not likely to give a true picture of what you're actually trying to analyse. Okay, so X-rays are absorbed by the Earth's atmosphere. Okay. B part 1. Well, this is in 2000. Such telescope was used to observe a black hole in Ursa Major. Okay. Explain what is meant by a black hole. So again, just a definition question. So the key thing with this is they just want you to state one thing about the black hole, not necessarily. They want you to specifically analyse how that black hole was created, or where it originates from, so to speak. It's not asking you what causes a black hole in order to describe it. It's simply asking you, what is that black hole? Okay, so you can kind of guess that because it's only worth 1 mark. Okay, so it's only going to be 1 point. So therefore, you don't need to build up an explanation of how it's created. It's just asking you what it is. And the key wording you need to use is basically you can class it as an object, or I mean you could put a collapsed star, but you don't need to go into more detail on that. I'm just going to label it as an object. Okay, so a black hole is an object where the escape velocity is greater than the speed of light up to a certain point, called the Schwarzschild radius, but you don't need to put that in. You just need to put an object where the escape velocity is greater than the speed of light. Okay, so that's all you need to put for B part 1. As I say, I'm just going to put in brackets. You could add on just to make sure you doubly get that mark. Up to the Schwarzschild radius. Okay, so that's B part 1. Okay, so B part 2 actually is the first part of the question, and I think the only part, if I'm right in remembering, and that actually asks you to use some kind of formula. Okay, so So the first bit of information is we're told that the black hole is believed to have a mass 7 times that of the Sun. Okay, now depending where you get your information from, in the question it says the mass of the Sun is 2 times 10 to the 30. If you look in the formula sheet, it's 1.99 times 10 to the 30. Doesn't really have that much of a difference, and it will take account for that. Okay, but as it's told you the mass of the Sun in the question is 2 times 10 to the 30, then that's what you would use. So the mass of the Sun is 2 times 10 to the 30 in kilograms, okay, and the mass of the black hole is 7 times that, so times that by 7, okay. That's also known as 7 solar mass, okay. So if the question said the mass of the black hole is 7 solar mass, it would be exactly the same as saying the mass of the black hole is 7 times that of the Sun, okay. So just be aware of that, and that would obviously be 14 times 10 to the 30, or you could just leave it as 7 times that, okay. So that is the mass of the black hole. Now we're not sure what we're asked to do with this yet, but it's likely we're going to need that. Calculate the radius of its event horizon. Okay, so this particular equation is given in the formula sheet. Now how this is derived, there are 2 methods, neither of which you need to know about, but please do check out my extra A2 physics videos that I occasionally put up on my channel that will tell you how we come up with this equation. But as I say, it's in the formula sheet, don't need to worry about how it comes up. Okay, but it's to do with mixing potential energies and kinetic. Anyway, I shut up. So the smallest I read is the square root 2gm over c squared, where c is the speed of light, r is the radius, g is the gravitational constant, and m is the mass of the black hole. Oh, is it not the square root of that? Oh, sorry. Is it not? Thought it was. One sec, I'm checking my phone. Thought it was. It's just my mad lances is the guy who's wrote them has not put the actual square root there. I'm fairly sure he is. Do apologise about this. I'll just be a second. I'm sure that's right. Come on, phone, load. Page. Come on. Come on, load. This phone's so slow. Oh yeah, there it is. Sorry, so 2gm over c squared, okay? And that's formula. Right, okay, so I asked to use all bits of information we know. So it's basically importing bits of information to a formula. It's very, very simple. I don't see why anyone in the A2 physics category would get this wrong. Okay, so it's Rs is equal to 2 times the gravitational constant, which is 6.67, times 10 to the minus 11, okay, times the mass of the black hole, which is obviously 2 times 10 to the 30 times 7, or you could work that out individually, doesn't really matter. It's all over c squared, which is obviously 3 times 10 to the 8, because we need it in metres, all squared, okay. So that will give you the radius of the black hole, which if you put into a calculator should get you 2.1 times 10 to the 4 or 2.08 times 10 to the 4, both in metres. Okay, now obviously you might not get your answer in metres if you don't use the correct formula. Okay, but sorry, if you don't convert the actually, yeah, you should get that. I don't see why you need to use any other units. Okay, but just in case you put this 3 times 10 to the 8 in kilometres, it'd be a bit different. But as I say, it is completely and utterly irrelevant because that's the answer you should get. Right, so it's 3b part 2. 3c talks about the CCDs. Okay, so I'm just going to move the camera down so you can get a bit of a more clearer understanding here of, because I'm just going to draw a little diagram and I just want to zoom in a bit more. You probably see my face a bit too much, but never mind, it's just a byproduct of watching my videos. That's just what happens. Okay, so the question actually says, Chandra makes use of a coupled charge device to detect X-ray photons and describe the process involved in the detection of photons by a CCD. So what you need to do with any question is pick out the key bits of information, and the essence of this is found in the second question, in the second sentence. We are describing the process involved in a detection of photons by a CCD. So basically, in other words, we're just saying how the CCD detects the photons, and in other words, how a CCD actually works. Now, there's no request for a diagram in this particular question, but I think it's probably worth showing one anyway, because there's only 3 bullet points you need to answer here, because it's only 3 marks, so you need to put 3 things, so therefore there's no need for an actual diagram. But I'm going to draw it anyway, because why the hell not? So, a CCD... Oh, pick a pen, it doesn't work. A CCD has these potential wells. Okay, now I've really crudely drawn it. Obviously you can just type in CCD in your Google Images and your one will go, what have your search history been? And you'll have to go, well, you can't look at it, I'm afraid. Anyway, well, for now. So these weird looking shapes that have no name are meant to represent potential wells. Okay, and a CCD is actually a chip. Okay. So the first point you need to state about this is the fact what a CCD actually is, before you state how it works. So a CCD is a silicon chip. You could just put a conducting chip, but a silicon chip is the right answer. Okay, so let's go through how this actually works. So basically, this obviously is the top of the CCD, and these are potential wells, which are filled with electrons. Okay. Obviously there's more electrons and they're betterly lined up than this, but just to obviously one negative charge. Okay, so what we have here is our instant photons, okay, giving rise the energy to these electrons, okay, and essentially they give this energy to overcome the work function. It's basically photoelectricity, okay, that's why you learnt it in first year. Okay, and they're therefore emitted with the kinetic energy left over after overcoming the work function of these CCDs. So how would you write that down in terms of this question, answering that? So obviously your first point would be stating what a CCD actually is. And then you would therefore talk about these potential wells. Okay, so we talk about the potential wells of electrons, the fact that they are in the CCD. That's your second point. And your third point is actually explaining the photoelectric effect. So your third point was saying the electrons, gain this energy from these instant photons, which overcome the work function and then are used to be emitted from the surface of the CCD, leaving a pattern on the CCD. So basically when these electrons leave, they kind of leave a pattern here, a certain pattern from when each electron was emitted, okay, and therefore when each electron is emitted, it will show you where the electron has been emitted from. Now the more that are emitted from a certain point, you know, more the energy, okay, has been concentrated on that single point of the actual of the silicon chip. Okay, now if there's been more focused energy on that part of the silicon chip, now we know, as you are aware, that the energy from that light obviously is an energy, it's a form of energy, and we know that obviously you can look at that depending on the frequency. Okay, so the greater energy, the greater frequency, so we can kind of tell what light is coming onto the CCD, so therefore using that analysis we can therefore say, well, if that kind of frequency is coming onto the CCD, then it is relative to this type of star. But obviously it's only worth 3 marks, you just need to explain how it works, you need to talk about the analytics of it, but just be aware, in a potential 6-mark question they may actually first of all get you to draw this diagram, or draw a sketch of it to show how it works, and also therefore analyse how the use of CCDs, so it might ask you to explain how they work and how they use that information to be able to actually work out what kind of star it is, okay? And obviously this therefore will give a pattern, as I said, it will therefore give kind of a graph or some kind of diagram, okay, to show what the energies are focused on look like, and obviously therefore you can use that to kind of say what kind of light it is, or what region of the visible or the invisible spectrum that light relates to. Okay, so essentially all you need to know is the fact is that for this particular question it's a CCD, it's a silicon chip, the potential wells in electrons, and then therefore say using those potential wells we've got this instant light, and then just explain the photoelectric effect, which we can all do easily. Now if you're resitting your first year units, okay, in other words if you're like an ex-student like me and just resitting your first year units because obviously you need 99.999% to do well, then that is a helpful reminder on the photoelectric effect as well. So thanks for watching. That's the end of question 3. It's, as I say, fairly short question. Most of it's written down. There's only one small part of equation usage, well, if that's even a word, it's now, I've said it. So that's all. Thanks for watching, and we'll see you in question 4, hopefully, if you're not dead yet.